In this video, I'm going to show you how to solve integrals using integration by parts. This is a useful technique when other forms of integration, such as inspection and substitution, fail. This right here is the master formula for integration by parts. The main idea is that we can start with a difficult integral and then pick some terms to represent u and v prime within the integral. Then, using our choices for u and v prime, we can re-express this integral as a different expression which involves an easier integral, v times u prime, inside the integral. So the tricky part is really figuring out what inside of the integral should we choose as u and what should we choose as v prime, so that the integral of v and u prime is an easier to compute integral. Now, to get a feel of where this integration by parts formula comes from, just think about the product rule on the product uv. If we take the derivative of uv, then using the product rule, we get uv prime plus vu prime. Then rearranging this a little bit, we can get uv prime equals uv, the product primed, minus vu prime. And then we can integrate both sides. So integral of uv prime dx equals integral of uv, the quantity, prime dx minus integral of vu prime dx. And we'll write this once more, simplifying. So we've got uv prime dx equals, now this integral is just the integral of the derivative of uv. So those cancel each other out, and we've just got uv minus integral of vu prime dx. So that's where it comes from. And we'll do a few examples to show you how to use the master formula to solve these difficult integrals that are going to arise. Here's an example of an integral which we can solve using integration by parts. So first of all, why do we need integration by parts here? Well, this x term kind of throws things off. If it were just the integral of e to the 2x plus 1, then we could solve that. But the x in front kind of makes it difficult. So we can't really do this by inspection, and then substituting e to the 2x plus 1 won't yield a derivative of x or anything. So this isn't going to work by substitution either. So we need to use integration by parts here. So in order to do integration by parts, let's write down the master formula first. So we've got integral of u times v prime dx equals u times v minus the integral of v again times u prime dx. So we want to choose u and v prime in this integral, so that way v times u prime is a simpler integral to solve. So we need to differentiate one term and integrate one term. We're going to choose x as u equals x. That way, when we differentiate here in the simpler integral, we get u prime equals 1. And then when this x term goes away, then this integral will be a lot easier to solve. And then, so that leaves us with v prime. That needs to be e to the 2x plus 1. And then we'll just take the antiderivative, v equals a half e to the 2x plus 1. And we're not going to worry about any constants just yet. We'll worry about that at the end. We'll just add our constant at the very end. So now let's go ahead and substitute into our formula here. So u is x and v is a half e to the 2x plus 1. And then we've got minus that integral of v again, which is a half e to the 2x plus 1 times u prime, which is just 1, and then dx. Okay, so let's simplify this and go ahead and solve. So this is x over 2 e to the 2x plus 1 minus integral of a half e to the 2x plus 1 dx. And there we go. Using integration by parts, we eliminated this x term, and now this integral is something that we know how to solve. So let's go ahead and solve it in the next step. So x over 2 e to the 2x plus 1 minus, this integral is a fourth e to the 2x plus 1, and then plus our constant of integration. And we'll just simplify a bit from here. So we've got x over 2 e to the 2x plus 1 minus a fourth e to the 2x plus 1 minus our constant of integration, and we'll go ahead and factor out 1/4 e to the 2x plus 1. That way we group up a 2x from this term, and then minus 1 from that term. And then minus c is just itself another constant, so why don't we just say plus k at the end, plus some constant k. And there we go. There's our solution to that initial integral that was hard to solve. Here's another integral in which we need to use integration by parts. The reason why we need to use integration by parts is that this integral would be easy if it were just the sine 1 minus x, but we've got an x plus 2 term in front. But by differentiating, we can eliminate this x plus 2 term. So we're going to set u to be x plus 2 in our master formula down here. U is x plus 2, which means that u prime is just 1, and that'll make the integral here a lot easier. And so then the remaining term, the sine 1 minus x, that has to be our v prime. V prime equals sine 1 minus x, and then taking the antiderivative, we have v equals cos 1 minus x. And again, we'll wait until this integral to think about any constants of integration. Great, so now we've got all of our u, v, u prime, v prime, and we can rewrite this integral using the rest of the integration by parts formula. U is x plus 2, and v is cos 1 minus x, and then minus the integral of v again, which is cos 1 minus x, times u prime, which is just 1, which will make this integral a lot easier to solve. So let's go ahead and simplify. So we've got x plus 2 cos 1 minus x minus the integral of cos 1 minus x dx. And this is an integral that we can solve. So let's write another line solving the integral. So x plus 2 cos 1 minus x minus the solution to this integral is negative sine 1 minus x plus our constant. And then we can go ahead and distribute the minus sign. So x plus 2 cos 1 minus x plus sine 1 minus x minus our constant. And then just to clean things up a tiny bit, let's write it as plus a constant. So we'll keep all of our other terms, then plus sine 1 minus x, and then we'll just write plus k for some other constant, because minus c is just a constant, so we can just call that k. And then that is our solution to the initial integral that was really hard to solve. Using integration by parts, we solved that integral. This was somewhat of a tricky example, but in the future, we'll see how to apply integration by parts to integrals which are even more complicated. It's a pretty useful tool.